Okay guys, let's derive equation for stationary wave. Alright, now stationary wave is combination of two progressive waves in opposite direction. Now we already have seen in my earlier video that progressive wave in positive direction of x-axis has the equation a sine omega t minus delta. Mind you, here we are taking it as small a. Alright, so this is small a, not capital A. I had written here capital A by mistake, but we have got to assume it to be small a because capital A is going to come later on. Alright, otherwise there would be confusion between amplitudes of individual wave and stationary wave, that is progressive waves and stationary wave. Fine. So y1 is equal to small a sine omega t minus delta, and where delta is phase, and it's also a sine 2 pi nt minus x over lambda. This derivation we already had seen. So what is important here is when it is towards positive direction, it is negative, and when it is towards negative direction, progressive wave, it's positive. The equation is the same, a sine omega t plus delta. Here it was minus delta, here it is minus x over lambda, here it is plus x over lambda. Now think of a string which generates two SHM progressive wave propagating in opposite direction. Now think of two SHM progressive waves propagating in opposite direction in long uniform string with equal amplitude and wavelength. That means this is one wave, progressive wave. This is yet another progressive wave having same wavelength, and same amplitude, having same wavelength and same amplitude. Alright, so this is what the situation is. Alright, this is progressive wave moving towards the positive direction of x-axis, and this is the stationary wave which is moving towards negative direction of x-axis. Alright, so we are going to derive equation for this. For equation for this would be 2a cos 2 pi x over lambda sine 2 pi nt, where this part we would use it as amplitude, this part would be the amplitude part. So the formula would get the form a sine 2 pi nt. 2 pi n we know is omega, so it is a sine omega t. So even this would be an SHM. Alright, because this is the desired equation for SHM. Okay, alright, now see, this is what I was saying, that here we would be having small a. When we do this, when we convert this into capital A, this would be the form of capital A. So that's the reason why I changed this capital A to small a. Alright, and that's how we represent it everywhere. Alright, whenever we talk in terms of progressive wave, we use it as small a, and whenever we are talking about stationary wave, it is capital A. Fine. Now let's get into the derivation. Alright, okay. As per principle of superposition of waves, the resultant displacement of particles in string would be y is equal to y1 plus y2, y1 plus y2. Alright, okay. So what we do, we just put in the formulae for both the equations. So what happens is, so this is formula for progressive wave in positive direction, formula for progressive wave in negative direction. Add up the two. So by formula c sin c plus sin d is equal to 2 sin c plus d upon 2 cos c minus d upon 2. Let's apply it to our formula. Alright, now in case of our formula, a we can take out as common. Alright, so what remains is sin, this we can take it as c, plus sin, this we can take it as d. Alright, so what happens? So the formula says 2, so this is 2, and this is a, common taken out from both, and c, so this is c, plus C, this is C, plus D, this is D. Alright, then comes cos, and then comes again C, minus D, so D is this entire thing. So when I open the bracket, obviously this plus becomes minus, and this plus also becomes minus. Alright, so now let's see what happens is, and forgot to say, divided by 2, divided by 2, divided by 2, divided. So C plus D divided by 2, C minus D divided by 2. Okay, done. So now what happens is this gets cancelled. This is minus 2 pi x over lambda, this is plus 2 pi x over lambda, gets cancelled. So what remains is 2 pi nt plus 2 pi nt, that becomes 4 pi nt, 2 cancels, so 2 pi nt remains here. So with sign remains 2 pi nt, and then here in case of cos, with cos what we find is 2 pi nt minus 2 pi x, then it was negative, so this became minus 2 pi nt minus 2 pi x over lambda upon 2. Alright, so that becomes what? That becomes, so minus and minus, so that becomes 4 pi x over 2 lambda, 2 and 4 gets cancelled to give you 2 over here. Now cos minus 2 pi x over lambda. Now if we come to our graph, we know that in first, if we say minus theta, it's anti-clockwise and it comes into fourth quadrant, and in fourth quadrant also minus theta. In fourth quadrant also cos is positive, owing to which cos minus theta is equal to cos theta. So even if it is cos minus 2 pi x over lambda, it would be cos 2 pi x over lambda positive only. So ultimate equation, ultimate formula for stationary wave is 2a cos 2 pi x over lambda into sine 2 pi nt. Now in this what we did is 2a cos 2 pi x over lambda, we take it as capital A, that is amplitude. So we fit in there, so it becomes a sine 2 pi nt, and we know that 2 pi n is omega, so a sine omega t. So two simple harmonic progressive wave combined together to give one stationary simple harmonic wave as per the formula. Alright, so what I was saying is, how do we derive this? So we derived the equation for stationary wave. Okay, alright, so this was the equation, and then this we termed it as capital A and got it in terms of SHM.